So I wanted to research whether or not we needed math instruction to get back to the basics. That includes both curriculum and instruction. I'm going to be talking mostly about some history behind the movements, talk about what the details of each movement are, and basically try to prove to you that we're asking the wrong question, that we actually have the basics right now and that we need to be moving towards something else. So, a little bit of the history. Early in the 20th century, fewer than 7% of 14-year-olds attended high school, and only half of those graduated. Most of those students went on to university to study higher level mathematics, but elementary school math was very much routine and process oriented. A quote from Alan Schoenfield is one set of instructions from a school district in the 1890s instructed teachers that their students were to learn no more mathematics than would to enable them to serve as clerks in local shops. Two major reform movements I'm going to talk about happened. The first in the 1960s, and the second more recently in the early 90s. In 1960, the reform focused a lot on problem solving. The reason that this came about is because the US lost the space race, and there was a real push for more students to study math and science. It turns out that in the early 20th century, only 7% of grade 8s or 14-year-olds attended high school, and that number jumped to 75% by the 50s and 60s. Real influences in this were Piaget and his stages of cognitive development, as well as his concepts of conservation and reversibility. This really emphasized the importance of having concrete examples and physical manipulatives. Brunner also influenced this movement. He had three different stages of mathematical representation, the first being inactive hands-on, the second being iconic with pictures and diagrams, and the third being with symbolic numbers and letters. The idea was to move from a concrete towards an abstract representation of math, and Brunner also really advocated for discovery mathematics. Again, with Herrera and Owens, they stated later in the 60s, Socratic dialogue and pedagogical approaches of discovery were relinquished for those backed by principles of behavioral psychology. And we see this reform go back to the basics in the 70s, where the curriculum and instruction really focused on the process of learning math and how to do math. The question is, why did we move back that way? So in the 70s and 80s, after we went back to the basics, there was a significant drop in American students' scores on national tests. Also, to back that, there were dropped scores in the trends in international mathematics and science studies. And these trends happened in the 90s, so 95 and 99. Let's first talk about the second reform movement. The NCTM published two major articles. The first being in 1989, the Curriculum and Evaluation Standards for School Mathematics, and the second in 2000, the Principles and Standards for School Mathematics. This really called for math curriculums to be viewed not so much as the order in which we teach it, but more of the connections within those courses, and try to really build on itself, follow a constructivist model. It really emphasized conceptual versus procedural, so to get away from how to do math and more about why we're doing the mathematics, and to try to connect the mathematics to the real world. I'll just mention one curricularist in here, Zalman Yusiskin, and in 1995 wrote an article with a number of other math educators, and one of the things they identified was something called SPUR, and this was the different ways of teaching mathematics and how to approach material. The S stands for skills, the P for properties, the U for uses, and the R for representations of mathematics. So we need to teach the skills and how to. We also need to teach the uses of it. We also need to teach the different representations that math can take. Where we're at now, Stiegler and Hebert wrote an article called Closing the Teaching Gap, and they analyzed the TIMS, I'd mentioned that earlier, the trends in mathematics and science study. And there was a 1995 video study that looked at three different countries, the United States, Japan, and Germany. And from that video analysis, they wrote The Teaching Gap, which looked at different forms of effective instruction. In 1999, the TIMS did a follow-up video study, and they included more higher-level achieving math countries: the United States, Japan, Australia, Czech Republic, Hong Kong, the Netherlands, and Switzerland. And what they did was they really wanted to look at what classrooms have effective instruction. Turns out the number one thing they came up with was that students need to wrestle with the mathematical concepts they're learning, and that they can't just have the procedures given. One of the things they discovered through the video study was that in the United States, and in North America for that matter, teaching in math has remained the same, process-oriented, almost since the start of the 20th century. And the other thing they mentioned in the article is that there's no effective instructional practice. So it's not just inquiry, it's not just direct instruction. None of those are cookie cutter, we follow it and it works. But it's more about the idea of how students interact with the material. So there's clearly a disconnect between curriculum and instruction. The curriculum is being written in a way but being implemented in a different. And the question is, why do we have this? Whiteford suggests that the problem why there's a disconnect is because mathematics instruction really needs to look more at teachers' attitudes and beliefs, that their philosophical differences are what really fuels the difference in how curriculum is implemented. In fact, she goes on to say that if we are to change the nature of mathematics teaching and learning, we have to look beyond the traditional views of mathematics as a fixed subject of absolute truths. So going not only beyond our beliefs around math education, but around mathematics itself. She suggests that there are two major camps, the first being the absolutist, who believe that mathematics is infallible, that it is an absolute truth and doctrine that we need to teach kids about, and the fallibilist, who believes that we no longer need kids to just memorize things, but we need them to interact and become social with the mathematics that they're learning. It should be mentioned that within both camps there are subsets and subgroups that she discusses, but for the purposes of analyzing back to the basics versus the conceptual and new math, these are the two major camps that I identified. So in conclusion, what I've tried to get across to you is that there's a relationship between curriculum, the educational philosophies of those teachers, and how that curriculum is instructed. We also need to look at how research views results and test scores. And we really don't have the new math yet. The way our classrooms are being taught math is that it is back to the basics. And we need to move that towards something that is more conceptual and higher level thinking and allow students to wrestle and interact with the math that they're learning. How that happens will require a lot more research and something that I'm interested in reading about.